One way that we get extra practice with the distance formula in our exercises is they're going to give us some ordered pairs, 3 namely, and if we put these 3 dots on the page, they would definitely make a triangle. But the question that we're being asked is, do they make a right triangle specifically? And what a lot of students are tempted to do is draw a picture and then try to say yes or no. Okay, if that's all you do for me, that's not worth very much in the way of credit or points. What we need to do is mathematically verify using distance and the distance formula. So when we were looking, find another page. When we were back at the beginning here of section 2.1, and we said, and we were trying to create what that distance formula was, we said, well, a right triangle always has the relationship a squared plus b squared equals c squared. And so if these 3 points that are there have gotten away from me there, if they do in fact make a right triangle, then it'll satisfy that relationship. Okay, so what we get to do, and these problems are just, like I said, distance formula practice in disguise. Okay, we're going to find distance between these 2 points, and we're going to find the distance between those 2 points, and then we're going to find the distance between these 2 points here. Let A3. Okay. And then we're going to see if they have the right relationship with each other. Meaning if the sum of the squares of the smaller 2 sides equal the square of the bigger side. Okay, now for the D1, D2, and D3, we will designate the biggest of those 3 distances to be our C, the equivalent, our hypotenuse, or that distance that we found in the last video. And the smaller 2 sides we will call A and B. So if you want to practice this without my jibber jabber in your ear, go ahead and pause the video and find D1, and then find D2 and find D3. I'm going to go through here in just a minute, and I'm going to keep on talking. So again, if you want to do this on your own, pause the video and leave me out of it. Turn it back on to see if you're right. So our distance formula says D1 is going to be the difference in the x coordinates. And it honestly doesn't matter which order I subtract them in, as long as I do actually subtract them. Okay, plus the difference in the y coordinates. We're going to square each of those after we subtract them, and then add them together, and then take the square root. So this becomes 6 squared plus 2 squared is 36 plus 4, which is 40. Okay. Now this is the one, when we're trying to check to see if we're making a right triangle, this is the one time that you're not going to get in trouble if you leave the radical written as square root of 40. It's actually going to make our arithmetic a little bit easier in a few minutes, and so you can actually stop there and not call that 2 times the square root of 10, unless you just really want to. Okay. So D2 is going to be the difference in the x's. 2 minus negative 1 squared plus the difference in the y's squared, which is 3 squared and 11 squared. 121 and 9 is 130. To find D3, we can take negative 4 minus negative 1 squared plus 3 minus negative 6 squared. Negative 4 minus negative 1 is negative 3. When I square it, I'm going to get positive 9. And we have 9 squared, so 81 and 9 is 90 under the radical. Again, even if these radicals simplify, I'm not going to worry about doing that at this time, because what I want to check, the relationship that I'm looking for, is I want to know, is a squared plus b squared equal to c squared? So it doesn't matter which one we call a and which one we call b of the 2 smaller numbers, but c has to be the biggest. Okay, so C is the 130 because it's bigger than 40 and 90. We can call the 40 either A or B and the 90 the other one. Okay. So the question that we need to ask ourselves is it true or false to say A squared plus B squared equals C squared? Okay. Right. From the things that we've been doing, we know that squaring the square root just gives us the stuff underneath. Okay. All right, so since this relationship was satisfied, we say these 3 points up here do make a right triangle. Make sure that you give me the word yes or no, or say right triangle or not a right triangle at some point in your problem when you're doing these out of the book. Okay, so we would say yes, these make a right triangle. Okay. All right, so let's, and I'm going to label these again. I don't remember what colors I used last time, but I'll use 3 colors here. D1, D2, D3. Okay, so go ahead and pause the video and find D1 and D2 and D3 and see if they have the same relationship. This is going to be the same question. Do these 3 points make a right triangle? Okay, when you turn the video back on, the answers are already going to be there. It won't be me talking through it, so don't turn it back on until you're ready to see the answer. Okay, so I did these in a hurry. Hopefully I didn't make any mistakes, but definitely give me a shout if you ever find a mistake in any of my videos because they happen from time to time. Okay, D1 is you're going to get 25 plus 9, which is 34 under the square root. And that doesn't break down, but remember, even if it does, we're not going to go there. On D2, you should get 7 squared plus 5 squared, and 49 and 25 is 74 under the square root. And for D3, you're going to get 2 squared plus 2 squared, so that's going to be an 8 under the radical. Again, I compare and find the biggest value, and that one has to be C. And then the other 2 become A and B in whichever order you prefer. And so we will ask the question, is the square root of 34 squared plus the square root of 8 squared equal to the square root of 74 squared? And it is not true to say that 34 plus 8 is 74. So we would say, nope, this does not make a right triangle. So practice these in the book. Be very careful here because if you do your addition or subtraction wrong, it is subtraction, but you know this turned into a plus and a plus. If you do your arithmetic wrong, then sometimes you're going to think yes when it's no or no when it's yes more often. So be careful to get to these A, B, and C values. Then from there, you're just looking for the right relationship.